Thanks, NVIDIA, and thank you all for being here today. I'm excited to share with you some perspectives today on video games, cognitive enhancement, and the future of how we can improve our brains. I just want to start with the goal. This is a goal that has driven me for 20 years in this field, to improve quality of life. It may seem like an obvious one for someone coming from the medical world, but I can tell you that this is not a goal that I share with all my colleagues. There are many people that are working on extending the length of our life, our lifespan. We already know that we pay a great burden for that. We have neurodegenerative diseases such as Alzheimer's that are reaching epidemic proportions as we live longer and longer. So I think the focus should be on living a better life. And that's what I'm here to tell you today, an approach to do that. So one way is that we can develop a system, an approach to enhance cognition, both in healthy and impaired individuals. By cognition, I mean how our brain processes information in its most fundamental ways, from attention, perception, memory, decision-making. When you think about this from the perspective of healthy people, you're essentially talking about what the core is, or should be the core of education, right? It's not just about transferring content, but actually improving how our brains process information. And when you think about this from the perspective of those that are impaired, it really is the goal of our mental health care system to improve how the brains of those that are suffering either psychiatric or neurological diseases, how they function. Unfortunately, our current system is really lacking in several ways, and I just want to present this with an example from my own field of neurology, although this example is applicable to other realms of psychiatry and neurology more broadly. Let's take a 60-year-old that goes to their doctor with the complaints that their memory and their attention is changing. So as you can see in this picture here, maybe some of you have experienced this as well. This is the frustration you feel when you arrive at the refrigerator, only to find that you absolutely have no idea what you're doing there, although you know 7 seconds ago exactly what you wanted to get. Has anyone experienced this in this room here? So, a couple of you, right? Maybe up front. So, in itself, this is not concerning, but if it occurs more and more frequently and your significant other is getting worried, this might be the time that you actually go to your physician and talk to them about these changes. And this is what happens, even at the best medical centers in the world. The first thing is that you get a very poor characterization. The doctor is unlikely to know exactly what's going on with you cognitively. If you're a neurologist or a psychiatrist, you're likely to get a better evaluation. But what's happening in your brain to lead to these changes is going to be entirely unknown. You're not going to really have any functional brain imaging of what the underlying cause of what's frustrating or concerning you. The other thing is that if you are going to get treated, if the doctor is sufficiently concerned, you're likely to get one of these, a pill. Unfortunately, these pills are very poorly targeted, right? So all the medications we have now for all psychiatric and neurological disorders are blunt instruments. They affect the brain rather globally. They might impact the neurotransmitter system, but they do not impact circuits in our brain, which is the selectivity that we really are looking for. And because they are so blunt, we have to increase the doses to high enough levels to get effects, and then we wind up with side effects. And much of what doctors do today is really just manage the side effects that are caused by the medications that we're using to treat whatever's concerning the patient. The next problem is that it's entirely non-personalized. So the prescription that you get is based on population data, but nowhere taking into account this individual's brain and the distinct aspects of how they process information and what's failing. And so this lack of personalization is a real issue because we know that the population that's studied is very heterogeneous. And so what might work for one person might not work for exactly another person equally. And this is the status that we find ourselves in now. The other problem is that the prescription is likely to be unimodal. And by that, I mean that you're going to get one treatment, likely a drug. Even though that we know from a lot of data, for example, that physical exercise is important for brain health, you're unlikely to see that in a medical prescription along with a pill. The last problem is that it's an open loop system. So I know a lot of people here are engineers, and I know engineers know quite well that if you want to change something, the approach you take is a closed loop system, meaning that when you do something, you record as rapidly as possible with as low latency what the effect was, and then you reapply based on that data, and you wind up with a feedback loop. This is how you change a system. This is exactly the opposite of how our current medical system works. We give you this pill with all these associated problems that I just described. You go home with it. You come back months later with a subjective impression about what changed in terms of effects and side effects. And then a decision's made, not on empirical data, about how to go up or down on the dose, the adjustments made, and months pass again. We have long latency and a lack of quantitative data that's used in that feedback. This is really just not good enough. This is not where we should find ourselves in 2014 in the way that we treat this wide range of diseases that inflict so many people. And so one of my goals, and the goal of my lab, is to create a new system. And we've been working on this for 10 years now, and we know that we have a long road in front of us. But I want to show you now an example of what we've done and where we're heading to create a system that's targeted, personalized, multimodal, and closed loop. If not to replace our current system, but to supplement it and make it much more effective. The first step is to understand the target, because if you don't know what the target is, you're unlikely to be able to have an impact. To do that, my lab uses these set of tools: functional MRI, EEG, transcranial magnetic and electrical stimulation. From this, we learn how neural networks in the brain underlie higher order abilities and how they change in different conditions, like aging, which is a population, older adults, healthy older adults that we focus on. Next, we try to build the engine. An engine of change. How do you build an engine? Well, how we built it is that we take advantage of this phenomena, brain plasticity or neuroplasticity. This is the ability of our brain to modify itself, its structure, its function, its chemistry, all in responses to new experiences. It's the basis of learning. For a long time, we thought that this ended after critical stages of development. We know that is not true, but this continues throughout your entire life. Our engine is just to harness this natural phenomena. If this didn't exist, I would not be speaking to you here today. It's the fact that our brain has this ability to modify itself, and that this ability does not go away and is always present, is really what we try to capitalize on and to harness. Let's take a look at the full landscape of approaches that might be used to enhance cognitive abilities. Well, first, you can apply a very particular and specific type of environment. This will drive plasticity in a way that you, as a society, feel is positive, right? It guides traditional education, other things like meditation, enriched environments. So if you apply a very particular experience, the brain will respond to it, and you could move a brain in a certain direction. The other approach that should be on the list is pharmaceuticals. Although they're blunt instruments, we know that they do have an impact on cognition because they impact neurotransmitters, and neurotransmitters are the guiding principle that governs how our brain processes information. So these drugs that are listed here were developed for medical illnesses like ADHD, narcolepsy, Alzheimer's disease. But we know, for example, drugs like Adderall are used on college campuses all around the world to try to boost cognition. So we want to keep those on the list at least as possibilities. The other is that physical exercise and nutrition. We know that things that are good for your body are good for your brain. Your brain is part of your body. We have an incredible amount of evidence that physical exercise, especially in the form of aerobic exercise, is important for brain health. Neurofeedback. There's an accumulation of evidence, although still in the early stages, that being able to see and hear and experience your own physiology, like a form of biofeedback, might allow you to be able to control it and improve how it operates. The other approach is neuromodulation. We can stimulate the brain electrically, magnetically, either internally through implanted electrodes or at the level of the scalp, and we're now accumulating data that you can actually change plasticity to increase it by applying certain currents, even in the form of very low currents, like a 9-volt battery, to the surface of the scalp. So these are things that we're considering and how they work together to improve cognition. I want to pause now and mention another one that many of you might be fond of: video games. We know that video games are now a global phenomena. The average age of a gamer is now in the late 30s. We know that they are more gender equal than they've ever been. I would propose that they are the most powerful form of media, given that they're both interactive and they're fun. And we know that they have a strong influence on behavior. That's obvious. The question is, can they actually have a positive impact? Can we think about video games beyond their role in entertainment? I want to read to you a quote from Time magazine from 1982. "Video games are just another manifestation of human mania, our endearing quality of going relentlessly after absolutely pointless goals." So there has been the view that video games really end right there. They're fun, but that's the most that they're ever going to do. There's now an emergence of really interesting data, not done by my own lab, but by others, showing that commercial video games, like action video games, first-person shooters, have been found to have an impact on improving cognitive control abilities in young adults that play them. So attentional allocation, resistance of distraction, working memory, task switching. And so there's this budding pool of literature that leads us to believe that these type of rich, immersive, fun, interactive environments might be a tool that we can shape how a brain functions. And so 5 years ago, I asked my lab the question, can we develop a custom-designed video game built from scratch to enhance cognitive abilities in older adults? So we spent years understanding what changes in the brain of older adults, so we knew what the target was. We understood the engine in terms of plasticity, and the way to harness it, at least our idea, was to use the mechanics of video games. And so I met with friends of mine that worked at LucasArts at the time, and I went to them with this idea of a video game to challenge older adults in the domain that they're most weak in, which is their ability to deal with multiple streams of information in a distracting environment. And this is what grew out of our research. And they told me that they'd be delighted to work with us. After spending their entire careers teaching teenagers how to kill aliens, they thought that this might be a bridge to something different for them. And I found that with supplying some sushi and beer, you can get AAA game developer, artists, video game programmers, developers in your lab to work with your postdocs and students and actually create something really new.